Question 7, doing some more rotations. I've got to draw these grids, but it's here on the screen anyway, so I'm not going to draw anything. I've got to copy these shapes. What you should do is put a piece of tracing paper across the whole grid, copy R onto the grid, stab it at the point 0, 0, that's the origin, and then rotate it 100 degrees. Makes no difference whether it's clockwise or anti-clockwise, you'll end up in the correct position. And imagine it's spinning around 180 in this direction, and the image will end up over here somewhere. Let's just put all the origins in, because this is what you should do in class with tracing paper. Again, you just shade out, or just draw the outline of the shape, and then just spin it round and see where it ends up. So let's just try doing this. I'll go that colour, see what happens. Try that. Which colour do I want? Go for that one. Right, so let me just try and work this out. Again, I can't pretend to even have tracing paper here. So I'm going to try and do this. It's not very clear. Start again. No, go a bit lower. Really difficult this. So 3 squared will be 3 squares. Again, you need to trust me that this works. And then of course you're going to try it in class yourselves. So there you go. It's as though I took this shape and spun it 180 degrees in that direction, and it's absolutely correct. Alrighty then, let's just try another 180. Let's try this one over here. Let's do C. Alright, so let's have a look. I'm going to do it mathematically because I haven't got tracing paper on the screen, obviously. If that's going to be 4, 2, I'm going to go -4, -2. So I'm going to start there, and if that's 2, 6, I'm going to go -2, -6. I think I'm going to do it like this, and that's 4 squares, so I'm going to go 4 squares like that, and then join the other ends here. Make a lovely, I think it's an equilateral triangle actually. Yeah, so that is the rotation, the image of the rotation of shape T 180 degrees about 0, 0. Alright, so it's all gone upside down around the other way. I'm happy with that. This one looks quite easy, so we'll do this one as well. So that's going to spin that way 180 degrees, or I could go this way anti-clockwise. Oops, didn't mean to connect that. Let's just do that again. Or is it straight line facility? Anyway, leave it alone. I can't get rid of it at the moment. So this is going to be here, like that. 3 squares across, come down 4 squares and join the ends at the bottom. As you can see, it's a very clear rotation. What's happened is that this has gone that way, 180 degrees, spinning around this point here. Alright, not difficult at all. So basically, this line here has become this line over here, I believe, and this line here has become that line there. Quite hard to visualise, but if you work with tracing paper, it'll be fine. This last one's quite difficult. I may need some help trying to do this one by looking at my notes that I've made. I think my starting point's going to be here. I'm going to go 3 squares this way. Then I'm going to go, I think it's about here. Very hard to do this. Again, tracing paper is lovely, but if you haven't got any, how do you simulate tracing paper on a screen working with a graphics pen and a pad? But anyway, that's what we've got. Hope you can see that. So this has spun around 180 degrees and gone there. Well, I could have gone this way anti-clockwise. Either way we end up in the same place. So this is R dashed, the image of R. This is T dash, the image of T. This is S dash, the image of S, and this is U dash, the image of U. Now in each case I've rotated 180 degrees around the origin. Please note the word origin, and the origin is the coordinate 0, 0 from which the axes originate. And I've not done any 90 degrees ones at all, or 270s. Again, it's quite hard trying to show this to be true on a screen, but you know, I feel a little bit inadequate about this. I'm sorry. It's got to be done practically on paper. Now this is going to be no harm done. Right, let's see if we can do this blessed thing anti-clockwise. So I'm going to spin it about the point -1, 1, and this will sort of come down here somewhere, and I believe we have an answer like so. -5 to -3, so that's going to be like that, I think. Then I'm going to come 3 squares down, 1, 2, 3. It won't look the same because I've stretched the image, but it's correct though. So that's that. Oh no, no. Let's get rid of that. I think that's just a slip there. Back to this, just straight down and a join up there. Okay, so 3 squares by 2, 3 squares by 2, but I stretched in a really funny way, so I'm sorry. So what I've done is taken this shape and gone anti-clockwise rotation like that about the point -1, -1. Again, you need to try it on real graph paper that's not been stretched onto a screen in any way like I've done it. Next one, I'm going to do shape H is what I've got here, I believe. Yeah, shape H or shape 2. And this has got to go, again, 90 anti-clockwise. It will go in this direction, like so, like that. And the centre is going to be -1, 1 again, so it's that one. The final outcome will be as follows. If I try and draw it, from -2, -2, so from there, and it's going to go to 1, -4. So -2, -2 to 1, -4 is like that. Again, it might look a bit skewed. And then I'm going to go down 3 units. So that's going to go down to -7. And then I'm going to just join the ends as best I can. So there we go. That is the 90-degree anti-clockwise rotation about the point -1, 1. Incidentally, please note, this part is represented here. This part is represented by this line here, and this part is represented by this line. Now, I don't know if you can judge it, but in each case they do look 90 degrees relative to each other. So that is 90 degrees to that, and that is 90 degrees to that, if you can visualize that. I think I'll do the next shape here, which looks terribly difficult. I'll do it anyway. Again, I'm still using -1, -1, so I'm going to spin it about there anti-clockwise. So this is going to go flying off in this direction, but spun right there. So this is what I've got. If I do it really carefully, I'm going to get this. That's going to go from -1, 2 up to -1, 3. So -1, -2, sorry, up to -1, 3. That's that part done. Then I'm going to go up to 1, 5, which is here, and then I'm going to go straight down to 1, 0, and then join the ends. Now that looks a little bit fat, but I assure you the coordinates are correct. Okay, so if I spin this shape at that point there, and then that will swing round, this will end up here, that will end up there, and this little part will end up right here. Alright, again, much easier to understand when working on proper paper with tracing paper, so you can actually try it out and try to demonstrate on the screen. So what I'm going to do is just carry on anyway and go straight to question 12, and let's see what we've got. Right, this is a bit slanty, but never you mind. This is question 12. For each diagram, give the coordinates of the centre of rotation as A is mapped onto B. Good language. Please note the word mapped. A is mapped onto B. A is transferred, transformed onto position B. Mapped is good. I like that. Right, 12. Now, how do we get from there to there? Clearly, we have a rotation of some sort. These are all rotations, and it's going to be, so I've got the centre there. I make that 3, 2. So if you imagine that being the centre, if you put some tracing paper over A, and you put a little stab mark there and rotate it, I think this should end up on this side, and this should end up on this side. You're looking at 180-degree rotation, about 3, 2. So you need to say 3, 2, rather than just put the little coordinate marking there. Now B is going to be, let's take a look. I'm going to get from B to A. Again, the graph is very skewed because of the way I've had to stretch the paper to fit, the JPEG to fit. So anyway, -2, 4. That's not too bad, is it? So I'm going to grab this thing and rotate A onto B. That will go in this direction, anyway, so that's going to be a 90 degrees C rotation about point -24. That's going to be a 180 degree rotation about that point. That's going to be a 90 degree clockwise, and it's just quite easy to see once it's drawn accurately for you anyway. And C is going to be 3 minus 1. I don't believe that. I don't think I'm going to get from there to there by spinning 3 minus 1. Might do. Anyway, I need to see how that goes in class. Anyway, the answer book does say 3 minus 1, and we can check it later. And that's going to be, if I'm going from A to B, then that's going to be anti-clockwise rotation. And that's going to be 90 degrees again, because this part lies down there, this part lies down there, this part ends up there. I'm still not sure about the 3 minus 1. It seems too far to the right, but it could be -1. No, -1 3 is no good. Could be -1 -3. No, we'll just have to let it go and see what happens. Or even 3 1 actually. 1 3. Right, we'll have to try it out really. So my feeling is it's going to be 3 3 1. But anyway, let it go for now, and we'll test it out in class. D. Well, this is D over here. Clearly, if you're going from A to B, that becomes that. So there's another 90 degree rotation, and it's clockwise. Apparently it's -2.5, -2.5. Right, so it's right there. Yeah, that makes sense. So hold it there, rotate clockwise. So that's going to be -2.5, -2.5. Again, these things really testing out in class with tracing paper, and that will go off in that direction and map onto B if you spin it at about that point there. Again, it's really hard to visualize. And E, 1 1 apparently. Yes, that's totally believable. I can see A landing onto B about 1 1. So this point will end up there, this point will end up there, and this point there. So that's coordinate 1 1, and that's a 90 degree clockwise rotation. And the last one, F, is a half 1.5. So it's right there. Again, very, very hard to see. So 0.5, comma 1.5. That's what it says here. And it's sort of spinning on itself, isn't it? And that's going to be 90 anti-clockwise, I'm sure. Yeah, 90 degrees anti-clockwise. And these are all rotations. So if I spin it anti-clockwise, that will lie across there quite comfortably. This part here will lie across there, and this one here would lie across there ever so comfortably. So that's a 90 degrees anti-clockwise rotation about the center of rotation, minus a half, comma 1.5. So a half, comma 1.5. And I think that's it for now, because next we're going to face some translations, and that's really, really good. Okay, so see you soon. Again, got to do this for real, got to do it live and active using tracing paper, and then you can visualize exactly what to do.